Hello, college or students. So let's take a look at how do we work with linear programming, or in other words, it's a linear optimization. So how do we solve problems? So this is a linear programming is a mathematical technique, right, for optimizing certain problems, right? Optimize to find the optimized solution for certain problems with some sort of a constraints or limitations or conditions or whatever you want to call it. So there's usually you're trying to optimize something, and then there are some conditions imposed on this. You cannot just take anything for granted. And then how do we do that? For example, let me give you an example. Let's take a look at this problem here. So suppose someone is about to take an exam that contains that contains computation problems that each of them worth 6 points, and word problems worth 10 points each, right? To do a computation problem, now you have some restrictions, right? Now there are some restrictions in here. To do a computation problem, it takes 2 minutes, and the word problem takes 4 minutes. And you have only about 8 minutes to take the test, and you cannot answer no more than 5 problems. As you see already here, it's not like the student. It's not that every problem were the same. Each problem has its own time that it takes, and then each problems have its own points, and then there's a total amount of time, and you cannot do more than certain things. So there's already a lot of restrictions. It's not like you have an unlimited amount of time. You have all the problems are same, or all the problems are going to take the same time, or all the problems are going to have the same number of points, right? So we have various different restrictions imposed on this particular test. So the question is, how do we maximize at the end of the day so what is your best strategy to maximize the score? How many problems that you should do? How many computation problems that you should do? How many word problems that you should do so that you can maximize your score? And then what would be your maximum score? So that is the kind of the problems that we are going to take a look at. We're going to solve. So let's take a look at how do we do that. Let me just try to set this up in this one, and then we'll see how do we solve it. For this particular problem, so you're going to take the test, right? There are two type of problems: computational problems and the word problems, right? So the number of so you're going to do some set of problems. So let's just say X is the number of computational problems that you're going to do, right? So it's going to be the number of computational problems, and Y is the number of word problems, right? Let's just say CP means computational problems, WP means word problems, and so on. Now, at the end of the day, what you want to do, you're going to get the score that you're going to get is for every X, right? For every computational problems, you get 6 points. So if you do X number of them, you're going to have a 6X. And for word problems, you get 10 points each. So if you do Y number of word problems, you're going to have 10Y. So therefore, that at the end of the day, based on your score, the score is going to be based on these two number of problems. So therefore, the total score would be, I'm going to say Z. Z is equal to 6 times the number of word computation problems and 10 times the number of word problems, right? That is what we call that's the objective function. That's what you're trying to maximize. You want to maximize your score. You are trying to have the best score possible in here. So you're trying to maximize your Z. But there are restrictions, right? There are some restrictions that is imposed on this. the uh, uh, the total number of problems, right? You only have 8 minutes, right? You only have 8 minutes. So if you do X computational problems, right? If you do X number of them, it's going to take you 2 times X number of minutes. And then if you do word problems, right, that's going to take you 4 times the number of word problems. And then all of these two together, right? All of these two together should not be more than 8. That's all you have, right? You have only 8 minutes to take the test. So here's a condition number 1. It cannot be more than 8 minutes, right? And then you can also you cannot answer no more than 5 problems. What does that mean? What does that mean? Um, so actually, I'm going to say this is less than or equal to 8 rather than saying 8. I'm going to say this is less than or equal to 8, right? You have up to 8 minutes. You might leave the exam early, right? You might finish the exam in 7 minutes or 5 minutes or 3 minutes and so on. So 2x plus 4y is less than or equal to 8. So the maximum is going to be 8. Similarly, the x plus y, the number of problems that you can, computation problems you can do, plus the number of word problems that you can do, cannot be more than 5 problems. That means that that is also going to be less than or equal to 5. So we have two conditions, we have two restrictions that are imposed on us, and here is a score that you're trying to optimize, right? So this is what we call the optimization problem or linear programming, right? So the idea is to optimize your score with respect to these two, in this case these two conditions. So let's see how do we solve these problems. So let's take a look at set of steps in solving how to solve these kind of these problems. It's called linear programming, also known as the linear optimization. So first you're going to do is you're going to find your objective function, just like we did earlier, right? You're going to find the objective function. That's what you're trying to maximize or minimize, right? And then by looking at the problem, you're going to write down the constraints, just like we did earlier, right? The constraints, and then you're going to look at the number of each inequality, and then we're going to graph them. So what are the conditions that we have, just like we're in section 5.5, we're going to graph, okay, this is a line, this is a circle. We have only deal with a linear one, so we're not going to have circle or parabola and so on, but let's just, we may have like a line here and another line there, right? And then you're going to say that's your solution space and things like that. And then you're going to have a shaded region. In that case, we're not going to find, for example, in this case, for a certain condition, here's a shaded region, right? You're not going to find, plug in all the values in here to find the maximum. What we are going to do is we're going to only look at the corners where they intersect, right? We're going to only take a look at these corners where they intersect, and we're going to plug these corners. We're going to plug these corners into the objective function. And then whatever the maximum, if you're interested in maximum, whatever is the maximum value is going to be the maximum, and whatever is the minimum value is going to be the minimum by just plugging in these values. So let me do some couple of problems so that you can kind of follow what I'm trying to say. So in this case, here's an example one. Again, this is just trying to understand how this process works, right? There is an objective function given to us as z is equal to 5x plus 6y, and the condition is given to you already. Somebody did all these legwork for you. What do I mean by that? Somebody did all these, did the step 2, did the step 3, and also did the step 4. We are only going to do step 5, right? So let's see how do we do that. So what we are going to do in here is we're going to take a look at the z, and we're going to plug in all these values, right? We're going to plug in these values, we're going to plug in these values. So let's take a look at the z. Z is equal to 5x plus 6y, and then I'm going to plug in 2 comma 10 here, and then see what is the value is going to be, and then do this, and then plug it in, and then plug these in, and then plug these in, and then see what is the value is going to be, and then the maximum value is going to be the max, and the minimum value is going to be the minimum, right? So let's quickly do that. So if I plug in 2 comma 10, I am going to have my z to be, let's make a table, and that might be a much better way to do this. Let's make a table. Here's my x comma y. Here is my x comma y, and here is my z. I think let's make this table a bigger. All right. So here's my x comma y. Here's my z value, which is 5x plus 6y. And if I plug in 2 comma 10, you see that your z is going to be 5 times 2 plus 6 times 10, right? Which would be which would be 10 plus 60, which is 70. If I plug in 7 comma 5, my z is going to be 5 times 7, 35, and 6 times 5, which is 30, so which is 65. If I plug in 8 comma 3, that will be z is equal to 5 times 8, 40, plus 6 times 3, which is 18, 58. When I plug in 1 comma 2, the z would be 5 times 1, which is 5, and then 6 times 2, which is 12. So 12 plus 5 is 17. So out of all these numbers, the maximum is this one, and the minimum is this one. So for this particular function, so if you take a look at this entire region, right, the maximum for all this is going to be, no matter what point you take, it doesn't matter. The maximum is going to happen at this particular point, that is 2 comma 10. The minimum is going to happen at this particular point, which is 17. So the maximum of this function, this objective function, is going to be 70, and the minimum is going to be 17. So maximum is 70, and the minimum is 17. And that's how basically they will do that, right? So the next step, what we're going to do is we're going to see how do we come up with this nice, graph, and then how do we figure out these corners is what we're going to do in the next set of steps. All right, let's take a look at this problem here. Find the mini and the maximum value of the objective function subject to the following constraints. So the objective function is z is equal to 3x plus 2y. The constraints are x positive, x greater than or equal to 0, y greater than or equal to 0, x is not negative, y is not negative, and 2x plus y is less than or equal to 8. And x plus y is greater than or equal to 4. So just similar to what we did earlier is what we are going to do in this case. In the previous section, right? So let's take a look at the constraints. So the objective function is given to us clearly, so no problem. Let's take a look at the constraints. So the first one says x has to be greater than or equal to 0. That means we are looking at, this region. We are looking at this region, right? Everything on that region. So I'm going to mark a line over here. I'm going to mark a line over here. And let's take a look at the second one, y is greater than or equal to 0. That means this is the entire upper half of the plane. That means I'm going to mark another line over there. So combination of these two, right, is going to be just this, right? So it's going to be, so if I put all these two conditions together, x positive, y positive, means this is first quadrant, right? This right here is what we call the first quadrant. And now let's take a look at the other restraints. 2x plus y, the good news is y is positive, that's a good news. 2x plus y has to be less than or equal to 8, and x plus y has to be greater than or equal to 4. So what would that mean in our case? Let's try to graph this one. If I try to graph that one, that is going to be, let me change the color. Let's try to graph this one in blue. When x is equal to 0, y is 8, it's right here. When y is equal to 0, x is 4, which is right here. So it's going to pass through these 2 points. So it's going to look like this. All right, not quite, but it's, you see that. And since it's less than or equal to 8, it's going to be everything below, right? Everything below. So it's going to be right here. So these three constraints are making it everything is below in here. Now let's take a look at the next one, which is x plus y greater than or equal to 4. X plus y greater than or equal to 4. What would that be? So let's take a look. When x is equal to 0, y is 4. Let me use a different color. When x is equal to 0, I'm going to use this color for this one. X is equal to 0, y is 4. It's right here. And when y is equal to 0, when x is equal to 0, y is 4, it's right here. When y is equal to 0, x is 4, it's right here. So if I graph that, that graph is going to look like this. All right. So here we have, and again, this one is above, right? This one is greater than or equal to 0 right here. So the region that we are interested in is going to be this particular region. It's going to be this particular region right there. Everything in here, right, is going to be the region that we are interested in. So let me shade it. If I shade it, let me shade it with the different colors so you can see it better. Let's go with some sort of a gray or something. So this is the region. So that is that region that we are interested in, right? All right, now, so let's take a look at the corners. How many corners am I going to have here? The corners here that I'm going to have are the following. I have one over here, I have one over here, and I have one over there. There's only 3 corners in there, right? So the corresponding values, let me write it down, are this is 4, 0, and this is 0, 8, and this is 0, 4. So we only have 4 points in here. So now let me make a table and then try to do whatever we just did earlier. So let's make a table, x, y, and then z. The x, y is, let's just go with the 4, 0 first. When I plug in 4, 0, z would be 3 times, z is equal to 3x plus 2y. So that's going to be 3 times 4 plus 2 times 0, which is going to be 12. When you plug in 0, 8, your z is going to be 3 times 0 plus 2 times 8, which is 16. When you plug in 0, 4, your z is going to be 3 times 0 plus 2 times 4, which is 8. So therefore, the minimum is going to be this one right here, and the maximum is going to be that one right there. If I try to make a table, table is gonna look like that. All right, so that's how the table is going to look like that. All right, and that's how we solve this problem. So here we can say the maximum is equal to 16, and the minimum is equal to 8. For some reason, I think I marked it wrong. So let's clear this up. This is supposed to be the maximum is 16, the minimum is 8, and that's how we solve it. Let's take a look at the next one. Find the mini and the maximum value of the given objective function that's subject to the given constraints. Z is equal to 3x minus 2y, and x is between 1 and 5, y is greater than or equal to 2, and x minus y is greater than or equal to 3. So the objective function is already given to us. That's like a step 1. Let's try to graph these things and then see how things are going to work. So the first one says x is between 1 and 5. So if I try to graph it, the x between 1 and 5, let me use the green here for that one. So here's my 1, here's my 5. So x is going to be between these 2 lines, which means that I'm going to make a line over here. Here's the condition number 1, and here's the restraint number 2. And y is greater than or equal to 2. We want the y to be greater than or equal to 2. So if you see here, x is between these 2, and y is on top of that, right? X is between these two and y is on top of that. So we're going to have this particular region as our region so far for these two conditions together. Let me change the colors for this one. So let's go with the blue in here. All right, so now the third condition is x minus y greater than or equal to -3. As I said earlier, I always would like to keep y positive. So if you rewrite this, let's use a different color. If I rewrite this, this would be y less than or equal to x plus 3. Y less than or equal to x plus 3 would be that one. So that kind of tells you that anything is below that line. So let's try to graph it. When x is equal to 0, from this, the line that I would get is y is equal to x plus 3. Let's try to graph that line. When x is equal to 0, y is 3. When y is equal to 0, sorry, when x is equal to 0, y is 3. When y is equal to 0, x is minus 3. So when so it's minus 3 over here. Y is 0, x is minus 3, which is right here. Let me go with a different color. Let's go with the red, so that one. When x is 0, y is minus 3, it's going to be right here. And when x is 0, y is 3, so it's going to be right here. So we have this particular line right there. All right, so here's the line right there. So therefore, this one says y is less than or equal to, right? So therefore, everything is below. Everything is below. So therefore, the region that I'm interested in is going to be this one. So let me shade it for you. If I shade it, the region that I'm interested in is this right here. That is the region that we're interested in. So now how many corners do I have? The corners that I have are this, 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 and this. So I have 4 corners. Let's take a look at these values. The values of these corners are the following. This is y is 2, x is 5, so it's going to be 5, 2. And here in this one, x is 5 and y is 8, so 5, 8. And this one is going to be x is 1 and y is 4, so 1, 4. And the next one is x is 1 and y is 2, so this is going to be 1, 2. So we have 4 points. Just like we did earlier, we're going to make a table and then do all that. So let's just write down the x, y. Write down the x, y here. And here's my z, which is 3x minus 2y. When we plug in 1, 2, the z is going to be 3 times 1 minus. I will stop it right here. We'll come back and do it later. So this is 3 times 1 and 3 times 1. Let me quickly do this. 3 times 1 time. I'll stop it right here. We'll come back to this problem later.